Hello, we're back. We're going to go and continue the ongoing struggle of programming Wordle. Let me go and get to the right page. Yeah, so we've done a good amount of coding. We are now halfway through implementing this, what I call the initial algorithm. I haven't thought of anything better than this. We described it in the last episode, number 9, in some detail, and the code is up there. And I just realized that the this algorithm is really not any place, and maybe what I'll do is put it up on the repo someplace. Let's just try to do that real cool. Let's try to do that right now. If I can do that. Let's see. Now, so this is the documentation of the initial algorithm, which is from this keynote slide, and I'm just gonna copy this thing. Just drop it in here so that people can access this, and I'm gonna put this as a H. Ooh, nope. I think it has to be. Alrighty. Yeah, okay. Yeah, I think I hit a shortcut key. Didn't know what I was doing. Yeah, so this part I want to make this kind of like a code block, but I'm just gonna put this here. Let's see, is this code? Yeah, but can I just I'm gonna use this preview, the input, and then this part here is the part that is kind of like a code block. Let's see what this looks like. Ugh. It's the new lines that I gotta deal with. Be cool if I could undo what I did. Nope. All right, so going back to this again, and thought that there was a way here to, oh right, code. I think I can do this, which is what we did in the README. Yeah, okay. Okay. Creates initial page. So I'm just gonna put this into our chat, and we now have this for posterity. This is the initial algorithm that we're trying to code. We can refine this once we implement the final algorithm, or rather we can add notes to this on what some of the considerations were. What I like that this is here is that you can see the initial thinking and compare it with the code. Let's see. Right. Then I'm going to. So we did that. I'm going to go to the Xcode. I didn't fire that up yet. The only topics that I had for tonight was one was to try to complete this, but the other thing I wanted to do was to add more tests. One of the things that we've been doing was testing against this very simple test case, which is crabs to craze. But there are a lot of other test cases, including these other variations that we see on this slide. But really, what we can do is create other scenarios that are valid scenarios. So I'm just gonna, for example, I'm gonna copy and paste this thing. I'm gonna say test update row, and I'm gonna put here first guess lucky, and I'm gonna say that the guess row was plant, and the correct word is plant, and you get it in one try. And in my own Wordle, according to the statistics, it says that I've gotten the Wordle on the first guess twice. But what I remember, the only word of those two that I remember is plant. I'll have to come up with the second word that I got on the first try. I think it was very soon after plant also. But the thing is, if we guess plant and the correct word is plant, then the row should look like this. Yep. I'm going to save this. We're going to go fire up this test. And see what it does. Yeah, once again, these numbers. I think these numbers must correspond to the, yeah, it might correspond to these logs. 1, 2, 3, 4, 5, 6, 7, 8. No. Okay, so the build succeeded, so let's see what that gives us in the test run. Xcode, you can do it. I think just some little behind the scenes information. I did update my streaming software, so it should work a little. It should consume the CPU less, presumably leaving room for Xcode to do its work. No, good. So this test passed, and that's a good thing. Now I'm going to try to create another test called update row. I'm going to say first guess no letters. So maybe the correct word is taser, but you put in a 5-letter word where none of the letters match taser. So let's make it, taser has all the common letters, so we'll have to do something like click. Yeah. So taser is the correct word, but click is what we put in. So the guess row will actually be blank. I don't know why I forgot I had VI mode. I can kind of go a little faster. So now let's run this test. And the testing in this fashion, kind of TDD, is quite powerful, and it gives you confidence that your algorithm is working. But clearly, it won't handle something like baton. So I'm going to put in here. Well, first let's add these two test cases in here. We got these two. Adds what I call two. I call them not outlier cases, but the kinds of test cases where it's extreme, I guess, is maybe a good word to put it. But anyway, adds two test cases. One is right guess on first try. I'm going to omit that. Remember, guess row is in our design just one object that'll be working in the game loop. It's the most important one, but there's a lot of other stuff happening here. Namely, we gotta we have to have a loop that runs 6 times. We have to grab a 5-letter word. We have to check if you got all the words correct. That's actually like guess row appearance. What would be a function that we would need to have so that we could know that is everything correct? That could probably be a function. We're going to get to that when we implement the game loop, but that's just a nuance. In the end, this is a guess row for one instance of a guess against a correct word. So there's no notion of a first guess or a third guess. All right, so I committed that. I'm going to push it. I sometimes forget to push this code so that we can see it if you're online here looking at this. Now that code is there, let's add a test for something like aroma. See how if you guess cured or tramp or walks, you're going to get one of these. So I'm going to put here a test called test update row. I'm going to say aroma. So the correct word is aroma, and you put in the word walks. And so this will be walks. And the only one that's correct is A, or the only one that has a indicator is A, and that indicator is minus, because that's how we're going to express when the letter is not in the correct spot but is in the word. So I'm going to save this. Let's run this test. And I'm naming these tests against the correct word. That's the convention here. But maybe I'll come up with a better one. In the end, these tests are just for me. As long as I remember what they're for. Yeah. So we already have an issue. Let's see. Yeah. Build time. I like how it's a build time, but anyway, you can see here walks is not equal to walk. So what we need is something to mark a letter as in the word. And that's what the second part of this algorithm is about. We have an array of correct letters, possibly modified by above. If you remember from the work we did yesterday, what we instead have is the correct word, possibly modified by above. What we have instead is the correct word where all the correct letters are removed. And what we have is called remaining letters. And what we're going to do is for every position or letter in the guess where it is not in the correct spot, we're going to compare those letters to see if they're in this one. And we'll just quickly visit the REPL here. How could we do that? There is a function in Swift. I think in here, standard developer, the standard library. We look in this. If we look in this web page, if we look at all these functions when they eventually appear, what we'll find is that there'll be a function where we can query whether a letter exists in a word. Now, I went about it a different way the first time I implemented it. But here what we have is the word first, function first. Let's look at this. Returns the first element of the sequence that satisfies the given predicate. What does it return? It returns the element. But a key of this algorithm is that when we find that letter, what we want to do is remove that letter from the list of remaining letters. So we have an array of these letters. So now we need to remove one of these letters. And we already saw how to do that here with this I thought we saw how to do this, but there maybe we did it in an earlier version. I've already forgotten. The key is that we need two things. We need to query whether a letter is in a word, and then once we find that letter, we got to remove that letter from the array. And the word, the array, that means the same thing here. So let's go and do this. We have remaining letters as characters. Array of character. I'm going to say none. We're going to say, let's put here remaining letters, append E. Okay, I got to use double quote, apparently. E, L, and I don't know, K. So now we can do a quick look at remaining letters. It's an array of 3 characters. We can now explore these functions, and again, we're exploring these in the REPL, but we're going to ultimately put these into the program. So here we're going to do something like where k. Boy, you want to. Cannot convert value of type string to expected argument type character. Oh, that's interesting. I think what I got to do is something like this. Okay, so I'm definitely not using this function right. Oh, brother. I got to do it this way, where I have to express a predicate. Let's do that, but I already know we're not going to use this. Where yeah. So this function returns the character that you're looking for, but look at remaining letters. The character is still in there. So if I want to remove it, what I'll need is something like, well, we already know that it's in there because there's remaining letters dot remove, and if I say @2, it'll remove this one right here. So I say that, it returns it. And now look at remaining letters. It's only got E and L in it, and that's what we want in this algorithm. So what we need is a function to return us which element in the array of characters to remove, and it turns out that we can do that with this first index. Returns the first index in which an element matches as predicate. Boy, I'm not really into this predicate thing. I could have sworn I had a different mechanism. But let's look at this. I'm going to say I'm going to put back in the letter K, and I'm going to say $0 equal K. Oh, brother. You see what I messed up here? I forgot the quote. I'm going to close it and... Oh, brother. I don't know how to get out of this. I'm going to say... I don't want to quit. Yeah, I think yeah, okay, so it caught me with the unterminated. Let's redo this and correctly finish it. Well, I'm pretty sure I had a different way of doing this in the other in the other code, in the offline code, and I think it might be this. Yeah, this is it. Of. So instead of doing this crazy thing, where we're using parts of the Swift language that I haven't studied yet, namely these predicates which have closures. What's this $0? I've seen these in other languages, and I've used it in other languages, but here it's kind of overkill. What we want is really to express something like this. So that's exactly what we need. And then we also have the remove. So we have these two features of the language. I'm just going to toss them into Xcode. And put this in here too. Yeah. So that's the basis of this. So what we now have to do is walk through the guess letters and see which ones are not in the incorrect spot. Which ones are not incorrect spot. So we'll do something like this loop for, I don't think we'll need the index. Look at all these errors because Xcode is just too impatient for me to do my thinking. Again, when the artificial intelligence wakes up, I'm just gonna, yeah, it's gonna be a great day for, it's gonna be a great day, I suppose, for programmers. So here, what we have to do is I'd like there to be a loop where I can fulfill a predicate. So let's look at that in here. Control flow. These are for in loops. And I thought that there might have been a way to yeah, nope. While, yeah. I remember this in like the early episodes of this YouTube stream that I'm doing, where I saw this picture, and yeah, I like that. Chutes and ladders, snakes and ladders. It's cool. Look at that. That's a little game right here. That's pretty cool. Conditional. Let's see. No. Okay, well, we'll just use a basic loop. I thought there was a cool syntax that I'm missing, but let's code that up for C in guess letters nope, not enumerated. In guess letters, we don't need the index, remember, but what we need to do is check if C dot incorrect spot is not equal to true, then we have to check. And what we do is we say if wow, one of the things that we don't know is what happens if the letter isn't in there. So let's just put in a fake letter here. So we got K. What if we put in Z? So it returns nil. So right away we can say there's this syntax that we use here. If let go back, which I like. I like this syntax, and I think this matches what we want to express, which is let the integer value 0 or higher. But if there is no integer value, nil, then we'll just put something here like this. Yeah, it doesn't say nil, but I'm going to try it. I'm in fact I'll just try it right in the REPL. If let I equal remaining letters first in of the, so this is the hope. We're going to put here print got z else no go. So right here what we've done is we've used the REPL to test out some of the language syntax. You can just, we could have just put that right into Xcode and compiled and ran through a test. But what the REPL gives us is that quick interactive feedback loop to see, oh, we're on the right track. And I think it's why I stopped looking at compiled languages early in my career, because I was impatient to try out my ideas. And I at least when I first got out of school and began to work, it's why I got really enamored with scripting languages like Perl and the little languages that come in Unix like awk and sed, because BC, you can instantly do things and get a quick response back from the computer, whereas when you're programming in C, you're, oh boy, you open the editor, you have to go write a file, you have to go and compile it and run it, and yeah. So let's go and code this up. I think, can I just copy this thing? No, we'll just keep going. If C is in the, if it's not in the correct spot, then if let idx equal remaining letters first index of, and what are we going to search for? Yeah. We're going to search for the first remaining letter where it's guess letters. I thought it would give me car here. Yeah. Brother, let's see. Yeah, that looks right. We're looping through the guess letters. We're checking in the remaining letters. Is there any character? Is there any? What is the index of the first letter that matches this guess? And if we get it, then we say C dot inward is true. It's not in the correct spot, so we just leave that false. It might be better to declare it, to specify it false, but if it's in the correct letter, then what we really want to do is also do this: remaining letters remove at idx. Yeah. And then, right, so what we'll do is, believe it or not, this is the algorithm. We're going to get rid of this. And let's just try the test again, the aroma test. And if this works, then we'll just call it quits. We'll leave it. We'll leave the rest of it for tomorrow, where we're gonna, I think, write some more tests and then just start figuring out about this dictionary thing. I haven't done a lot of offline work with that yet, so I gotta really, I gotta do some live coding is what I gotta do. Okay, so aroma works. And that here implements the second part of the algorithm. So I'm gonna go and let's see what we have here for changes. The changes was to add the second half of the algorithm. Let's make sure that there's nothing else. Yeah, remove matching, set it to word. If there's it, do nothing. So that looks right. And here's the test. I'm going to say I'm going to put here test. And right. All right. Well, we did it. We got through it, and there's going to be more to come tomorrow. More tests. We're going to start trying to think about this checking for words business. And if you saw this page here, we're going to probably use something like this, and just see what it's like. The other thing that we can do tomorrow, though, in addition to more tests, everything. So yeah, that's what we could try tomorrow. We'll catch everybody then.